Some basic tools you're going to need for electrical diagnosis. You're going to need a bright flashlight so you can see wire colors and see what you're doing, taking stuff apart. Multimeter you're going to need. Most of the times I don't use my snap-on meter. I'll use a Harbor Freight one because the fuses are a lot cheaper. Electrical tape if you're going to strip some wires and twist them together, see if it's a temporary fix until you solder it. Razor blade or dikes. If you're going to strip some wires back, makes it nice and easy. Pick tools. I got the snap-on set. You don't need to spend that kind of money. These are Harbor Freight also, and you can pick those up for like 99 cents or something like that. Alligator clips, nothing fancy. These are cheap. It's just this has to make a connection. That's it. So if you're clipping onto some of the male plugs, like the harness side of the oxygen sensor, or some of the other connectors that are under the hood, I use this little guy. It's just a regular male spade terminal. It's good for probing into the relay. You can just stick your meter right in that little hole and just let it sit in there. Plug this into the pin of the relay and you get a good connection that you don't have to hold or have somebody else hold. It's a lot easier doing it one person if you got something to stick in there. I got a Jeep KJ I'm working on over here. It's a 2002 Liberty Sport. I was coming up with some problems. I was getting a bunch of O2 sensor heater faults, and I finally found the problem. So nobody's got a good video on YouTube about how they fixed it, or if you look around in the forums, they just tell you a bunch of garbage, and they just say they dropped it off the dealer fixed it, good to go. So here's what I found. I diagnosed the problem, I found the problem, and here we go. Alright, this is your O2 sensor circuit. Here is the upstream sensor that was having the problem, and this is your heater circuit, and this is the signal circuit. Signal circuit was fine, but the heater circuit, there was no power going to the connector, which is down here. I still have unplugged this connector to the harness, which goes back to the upstream oxygen sensor here. I started out with the basics. You know, this car has 200 and something thousand miles on it and original oxygen sensors. So start out with the obvious, replace the sensors. And as I've learned in the past, if you use an aftermarket Bosch sensor, they don't always communicate properly. So either it'll give a bad signal, or when the PCM is testing the heater control circuit, basically the resistance between this wire and this wire, and then it goes down here to the heater control of the powertrain control module. So the powertrain control module measures the amperage, and it'll say, alright, something's wrong. So get dealer oxygen sensors, and I just replaced them all anyway. So here we go. We'll start from the beginning. I'll put a link in here so you could skip to the end if you don't care about this. Auto shutdown relay. That's a problem for a lot of cars. And it was a problem on this one because there was a ton of corrosion and garbage and junk in the fuse panel over here. So here's the fuse for the auto shutdown relay, and this is the relay here. And it goes there. But here's a relay. So first thing you do, test the relay, but chances are if your car is running and starting, the relay's fine, and the circuit for the rest of everything is fine. So I just have my meter plugged in. This is pin 87. I just put a spade terminal in there so I can stick my meter in there so I don't have to hold it. Keep that on there for a second. And basically you have to make sure there's power to the auto shutdown relay, pin 87, which if you look at the back of the relay, you'll see one marked 87, which is this guy right here. So when this is flipped over, that's the top pin as it goes in. So easy enough. So pin 87, there's a wire that comes down here, up and around. This is basically internal in the fuse panel, and it goes to fuse 16, which is a 15 amp fuse, and that's this blue one right here. So you test ohms on your meter from this pin 87, and you come over here to this fuse. So pop it out quick. So you go 87. Bring my meter over here. Put it on ohms. Every meter is different. So you put it on ohms, and you test it to that pin, which is connected to the fuse, which gives power to the fuse. So as you see in the diagram, the auto shutdown relay, it doesn't show you the rest of the diagram, but the circuit goes from battery positive, which goes to the battery. This is your positive input for the fuse panel. Then it goes to this relay, or this fuse here. It's a 30 amp. Make sure that's good. And then so it goes from the 30 amp fuse, and then it goes to 87A until it's switched on. When the PCM says everything's good, switch on, it goes to 87, and that's where we're testing here. So when the relay is energized, 87 gets power. It comes up and over here to pin 16 of fuse 16. So this is pin 16 of fuse 16. And you hear the beep. We have 0.1 ohm resistance. So we know that circuit's good. To point out before I go any further, it doesn't matter if you spend $300 on a meter or if you spend $10 on a meter, there's going to be resistance through the meter leads. So you're going to drive yourself crazy looking for different resistance values if you don't check the resistance of your leads instead of baseline. So right now they're not connected. It says out of limits. So when you connect them together, I have 0.1 to 0.3 ohms of resistance that it's measuring through my meter leads. My Harbor Freight one over here has about 0.6 to 0.8 ohms of resistance. So if something has a perfect circuit, your meter's still going to read, 0.1 to 0.3 or 0.6 over here. So that'll drive you nuts if you're trying to make a perfect connection. So I'll just check that first so you know exactly you're measuring resistance through your leads. Now for the rest of it, it goes from the relay to the fuse. So if you try testing later down the line and the fuse isn't connected, then you have a problem. So here we go. Put the fuse back in it. Alright, now we completed the circuit, because before we took this out, which isolated this wire from this wire. So now that that's a direct connection, the fuse is good. Now we go further down the line. These are the two wiring diagrams for each oxygen sensor. You have all 4 sensors on here. Bank 2 sensor 1, which is before the cat, right out of the engine on the passenger side. This is bank 2 sensor 2, which is after the cat on the passenger side. This is bank 1 sensor 1, which is before the cat on the driver's side, and bank 1 sensor 2, which is after the cat on the driver's side. So before you even start, the faults I was having was bank 2 sensor 1 and bank 1 sensor 1 heater control circuit. So if you look at this diagram here, this is, I didn't have a fault for this side of the oxygen sensor. This is your signal as it's measuring how much oxygen is in your exhaust. So both sides of this loop around. You have the ground, signal, and this reports back to your powertrain control module. So I didn't have faults for the signal, I only had faults for the heater. So scribble out all this stuff so you don't drive yourself crazy looking at too many wires. So same thing on this side. My fault was for bank 1 sensor 1 heater control circuit, bank 2 sensor 1 heater control circuit. So get rid of everything else. Now what you need to look for is common wires between both, because 9 times out of 10 it's going to be a common wire that's the problem. So if you look down here, this goes to pin 16 on connector 3 of the PCM. This goes to pin 8 on connector 3 of the PCM. This is a different plug. This is on the driver's side, the plug that has these 4 pins in it. So on the driver's side, this is on the passenger side. So it's rare you're going to have 2 plugs that are bad. So we know we can get rid of this. This wire we don't necessarily have to look at, and this wire we don't necessarily have to look at. But if the rest of the circuit tests fine, then maybe you have a break in this wire and this wire. It's rare, but it does happen. But 9 times out of 10, get rid of the uncommon wires. So let's see what what circuits these 2 sensors share. Okay, this one here, we'll test this one. Connector 105, dark green with a red tracer, goes to connector 105, splice 170. Dark green with a red tracer, connector 105, splice 170. Dark green with a red tracer, dark green with a red tracer. So this splits at the splice, comes from the fuse, splits at the splice, goes here, splits the splice, and goes here. So this shares power to both oxygen sensors. So more than likely, from the splice to the sensor will be good, and from the splice to the sensor will be good. But don't rule out that splice. That's a common splice which splits off this wire to go to this sensor, and splits off this wire to go to this sensor. So that should be a place where you look, but we'll start with the rest. That narrows down almost the entire circuit. So, alright. Both of them share fuse 16. So now you have to test between the fuse coming out of the fuse panel around the front of the truck, I'll show you that in a second, down to the splice. So if your fuse is good, you have continuity between here and here. This relay is your auto shutdown relay. This will not energize unless you have the key on. So turn your key on, see if you have power at pin 30 on the relay. And some people jump these and get rid of the relay, but I wouldn't recommend that. Just let it do its job. If the powertrain control module sees a bad sensor reading, it will shut this off. It kills spark and fuel to your engine to prevent it from exploding. But if you're in a pinch and you think everything's okay, jump it, but don't tell anybody I told you that. So, relay to fuse, relay to fuse. Fuse 16, fuse 16. So this is a common circuit. So if you have power at the fuse, then you're good. Then you get rid of this also. So as you do it, as you check different things, cross it off. That's what printouts are for. If you have a Haynes manual, probably shouldn't do this. So we just narrowed down the entire circuit. So this big ugly mess turned into, you have to check why there's a problem between this pin of the fuse and this splice. There's a connector in the middle, so fuse to connector, connector to splice. There's a problem. And both of these circuits share this common single wire, splits off, goes to each oxygen sensor. So double check. Connector 105, dark green, red wire, 18 gauge. Same thing, dark green, red, dark green with a red stripe, 18 gauge. So there's some problem from here to here. I might add links to these just so you can see what I'm talking about here. So this is connector 105, and this is facing forward, so this is going to be on the passenger side between the firewall and the fender. Right in front of your transmission computer, plugs into this plug. So 105 is this group of 3 connectors, and it's going to be the top left when you're standing in front of the headlight looking at it. So let's go over to that. And this is connector 105, and this, I believe, was mislabeled. So this diagram says the one on the top is 105 and the one on the bottom is 104, but this is actually the 105 they were speaking of. So you go to connector 104. So this is connector 104. And now you're looking from this side. This was actually on the bottom. This connector was on the top. This connector was on the bottom. So it's gray on both sides, at least on this year. The one on the top that was labeled 105 was this one that was black and black, but the real 105 is gray and gray. So you go to pin number 5. So that pin's empty. That's pin 1, pin 2, pin 3, pin 4, pin 5. You see it's green with a red tracer like it said in the diagram. And these are the male pins, so I have a alligator clamp connected to that one. So now we test the circuit from over here. We will be testing, since we know this connection, this circuit's good from here to the fuse, which we tested earlier. So pin 87 to the fuse we know is good. Fuses are mini fuses, so they're kind of hard to probe into. I don't have the kit for these, only BMW. So I'm going to leave on pin 87, and we're going to test to the connector. So here we go. This one's plugged into pin 87. And we're going to run this over here. It's going to be plugged in to pin 5 on the male pin. Just make sure you got a good connection, and you get these cheap alligator clips that got the little shield over them. So now we clip this on, and we have continuity. You can tell by the beep. So when I was testing, I didn't have that. So it said there was an open circuit between 87 and here. So the path that this follows is it comes out down here, and these wires actually loop around and come around front to go to that other connector. And it goes through this wire harness that's behind this plastic piece, and it goes around to this side where my problem is. So this was the green with the red tracer, and you can see by my my quick little twist connect there. There was a broken wire right there. I tugged on the harness a little bit and it split. And this plastic piece behind here, I don't know if you can really see it in the video, but this plastic piece fell to a million pieces, probably from an accident or something. This is not where it's supposed to go. And there's a lot of other wires back here that kind of look shady. You know, this one's got a split in it. You can see the red with a white tracer right here. There's a, you can see the wire exposed, and you can see the same thing in a couple spots on this wire. So I peeled the tape back a little bit, and I just tugged on this wire a little bit, and it split right there. So there was no electrical connection. It was just the insulation holding it together. So then we test the opposite side of this plug. So you go to pin 5, you go 1, 2, 3, 4, you can see that, 1, 2, 3, 4, 5. We go to that one, and then I tested resistance to the harness side of the oxygen sensor plug, which I believe it was one of these top ones where the push pin is. One of them's go to your PCM for the ground, and the other top one is going to go to this connector for power. The other two are, the bottom ones are signal wires that go to your PCM. So test one of the top two, and if it says no resistance, you know you're good. But if there is resistance there, if you look back here, that gray plug, this one here is the other end of the plug that I'm connected to, that runs up here, and then in this, you see that plastic shielding back here. Let me see my finger, there it is. There's this plastic cover that just looks like this when you pull it apart. It's just a little plastic shield, and I have this one pulled up because I was testing the wire throughout the circuit. So push this back down, snap it together. I'm not going to do it yet because I got some wires to straighten out, but that's what it looks like. You just get your finger under here, pick it up. It's got these little snap clips, pretty easy. But that goes up and around, and then in this area there's a splice, because it's the same power that goes from oxygen sensor on bank 1 and the oxygen sensor on bank 2. They get the same power, which goes through that wire that was broken that I showed you. So between the fuse and the connector, this little section of the diagram goes from the fuse panel down around the inside, down underneath the front of the radiator, up and around, and goes to that connector. So between the fuse and the connector is quite a bit of wire. So further down the line, if you find a good connection here, plug the connector back in so you're not chasing your tail. Complete this circuit. So if it's no resistance to here, come further down the line, splice 170. So go over here to the splice sheet, and here is splice 170 that I was telling you about. It goes from this connector up and around, and then splice 170 is where it splits off between the two oxygen sensors and goes to the other one. So if you still have a problem, check the splice, and then you got to start digging, because this harness comes back here, and then it looks like along the top of the fuel rail, in the fuel rail area by the injectors, you have this clip connector here, and then here's a common problem. This piece of the harness actually holds that same wire, and it comes down the side of the engine and spits you out right here at the O2 sensor plug. So there's your full circuit. It's just a mess getting back there. You got to take a bunch of stuff apart. So first, before you do anything, if you want to test that whole circuit, nice and easy, You go to pin 5 on the connector that I'm not connected to, and then set your meter to ohms, and you check it on one of these pins down here. I believe it's the top left, but I'm not quite sure. It could be top left or top right if you're looking at the pinch clip. So to check to see if this whole section's good to the splice, put your meter on here, use an alligator clip to hold it on the pin so you're not killing yourself or you don't need 20 hands, and then just gently use the probe of the meter and just touch the connector. I bent mine so it's easier to get at stuff and I can see what I'm doing. But like I said, you go to pin 5 on here, and you can see on the back of the connector the dark green with the red stripe. So touch that pin to that pin. I had 0 ohms of resistance and 0 ohms to ground. So that's another thing you got to look for. If, say, this wire that I have twisted together here, let me see that. If that wire was touching anything metal, like your radiator, you know, front bumper support, radiator support, or anything, if that's broken, not necessarily here, but you could have a break anywhere in the line, but if that's broken and touching ground, you're more than likely going to pop this fuse. Going to send high voltage, you're going to pop this one. And if you keep replacing it, it keeps popping, there's a problem. So there you go, there's a full circuit and some basics on how to diagnose it. So I'm going to take this thing for a test drive and I'll get back to you, because the only codes I had coming up were, I believe, P0031 P0051, and then I had a bunch of pending faults for the supply line of this circuit. So I'll get this thing back together and we'll go from there. Alright, so here we are inside the Liberty. I took all the trim pieces off because I had to pull the cluster out and replace a bunch of bulbs back there. It was not too bad to get the whole thing apart in like 20 minutes. And there's a lot of good videos on YouTube if you're interested. But got my $10 OBD2 reader, and I'll be right back. I'm going to clear the light out. Check engine lights on even when you run it, so maybe I can get this thing to pass inspection today. It's still 2 o'clock, should be alright. It just needs a drive cycle and get all the monitors to set. So I'm going to clear the light out, go for a test drive. I know my circuit's good now. I know the O2 sensors are brand new. So if it still comes back with that fault, it needs a PCM. So we did find a problem, fixed it, sort of. I just twisted it together and electrical taped it. I didn't solder it yet, but I want to make sure that's the only issue. One thing you have to keep in mind is the wires in the front that look really bad. They're going to be, even if there's one strand of a wire connected, you'll get a good resistance reading. But under amperage, if there's only one string, like one of the copper wires, because it's a bunch of wires twisted together throughout the whole wire, if there's only one of those connected somewhere else, it's either going to burn it out or it'll still give low amperage readings somewhere else along the line. So something else to watch out for. Just keep that in mind. Alright, here we are, brand new New York State Safety and Emissions Inspection sticker. It worked. Show you real quick. Still gotta put all this junk back together. Check engine light stays out. Gauges obviously don't work. I gotta fix that next. But check engine light still works even though the gauges don't. And all your idiot lights still work. So there you go. It's about 4:15 now, so you know, a little over an hour for a drive cycle, an hour to have them check it over and inspect it, and we're good to go. Fixed.